Hi everyone, this is your math guru. In this video, I'm going to be solving the following exponent with numerical basis without the use of a calculator. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first example, we have 5 to the power of minus 200 minus 5 to the power of minus 198 all over 5 to the power of minus 199 plus 5 to the power of minus 200. Because you have minus and plus separating each term, I'm going to look for a common factor. Because the powers are negative, the biggest number is your minus 198 and the smallest is minus 200. So I'm going to be using my biggest, which is minus 198, as my common factor. So breaking down each exponent to make it easy, I have 5 to the power of minus 198 times 5 to the power of, to make 200, I have minus 2 minus, this remain the same, 5 to the power of minus 198. And for the denominator, I have 5 to the power of minus 198 times 5 to the power of minus 1 plus 5 to the power of minus 198 times 5 to the power of minus 2. I got that using laws of exponents, which states that if I have the same base, if I have x to the power of y multiplied by x to the power of z, because the base are the same, I'm going to be adding the powers, so that will be x to the power of y plus z. Now, if you check my expression, 5 to the power of minus 198 is common to each term, so I'm going to be factorizing that out. That will be 5 to the power of minus 198 in bracket, because I'm factorizing, 5 to the power of minus 2 minus 1 divided by, this is equal to 5 to the power of minus 198. I'm left with 5 to the power of minus 1 on my left, plus, and on my right, 5 to the power of minus 2. This cancels, because 5 to the power of minus 198 divided by 5 to the power of 198, that's 1. And in my bracket, for my numerator, 5 minus 2 is the same as 1 over 5 squared, positive 2, minus 1 over, I'm going to do the same at the bottom, 1 over 5 plus 1 over 5 squared. I got that from the laws of negative exponent, which states that if I have a to the power of minus x, to make it a positive exponent, I change it to 1 over a to the power of positive x. Going ahead, I have 1 over 5 squared. 5 squared is 1 over 25. 25 minus 1 over 1 over 5 plus 1 over 25. If I check all the denominators, the lowest common denominator is 25. So I'm going to make all my denominators 25. I can do that. For my numerator, I'm going to multiply both the numerator and the denominator by 25. That's over 1. I'm going to do that at the bottom. That's times 5 to make my denominator 25. Simplifying, I have for my numerator 1 over 25 minus 25 over 25 all over, for my denominator, 5 over 25 plus 1 over 25. Laws of fraction, once the denominator are the same, then I'm going to add or subtract my numerators. So at the top here, I have 1 minus 25 over 25 all over 5 plus 1 over 25. I'm going to continue up here. 1 minus 25 for my numerator at the top, that's minus 24 over 25 divided by, I'm going to make that the division sign. For the denominator, I have 5 plus 1, that's 6 over 25. That's equal to minus 24 over 25 times, I'm going to flip my right hand side. 25 here 1, 25 here 1. I'm left with minus 24 over 6. And minus 24 divided by 6, that's minus 4. In my second example, I have in bracket root of 7 2011 minus root of 7 2009 divided by root of 7 2008, all plus root of 7 and all squared. I'm going to be selecting the power that is lowest, and in this case that's 2008. The radical law states that if I have square root of a, b is the same as square root of a times square root of b. And also I'm going to be applying the exponential law, which states that x to the power of a plus b is the same as x to the power of a times x to the power of b, because the base are the same. So breaking down what I have in the bracket, that's going to be root of 2008 times, to make 2011, 7 to the power of 3. Remember, I'm solving without the use of a calculator. I have 7 2008 times 7 to the power of 1 all over root of 7 2008. That remains the same, all plus root of 7 and all squared. Factorizing, at the top I have in bracket root of 7 2008 in bracket root of 7 3 or 7 cube minus roots of 7, and at the bottom I have root of 7 2008 all plus root of 7 and all squared. Simplifying, this cancels, this goes here 1. I have in bracket root of 7 cube minus root of 7 plus my root of 7 all squared, minus 7 root of 7 plus square root of 7, that cancels. I'm left with in bracket root of 7 cube all squared. The square outside here cancels my root, and I got that from, if I have root of x all squared is the same as, if I change my root of x, that'll be x to the power of 1 over 2 to the power of 2, laws of exponents, and multiply this, that'll be x to the power of 1. So I'm applying the same rule. The square outside cancels my root inside. This is, or I'm left with 7 to the power of 3, which is 7 times 7 times 7, which is the same as 343. Let's look at another example. In my next example, I have root of 2 to the power of 1002 in bracket 1 plus 2 to the power of 4 all over 17 2 to the power of 998. Applying the laws of exponents, x to the power of y divided by x to the power of z is the same as x to the power of y minus z. So having my root still, I have 2 to the power of, at the top, 1002 minus the base of 2 at the bottom has a power of 998. I've taken care of the root with a base of 2. I have in bracket 1 plus 2 to the power of 4. That's 1 plus 2 to the power of 4 is 2 times 2 times 2 times 2. That's 16. Close bracket. And on the bottom, I'm left with 17. That's equal to root of 1002 minus 998. That's 2 to the power of 4 in bracket 16 plus 1, 17, all divided by 17. This cancels. 17 here, 1. 17 here, 1. I'm left with square root of 2 to the power of 4. That's the same as 2 squared, and that's 2 squared is 4. I got that from 2. If I have square root of 2 to the power of 4 is the same as 2 to the power of 4, all raised to the power of half. Applying the laws of exponent, 4 times half is 2, so that's 2 to the power of 2, which is 4, which is what I have here. Let's look at one more example. In my last example, I have square root of 10 to the power of 2009, all divided by root of 10 to the power of 2011 minus root of 10 to the power of 2007. I'm going to be using the smallest power to factorize, and that's 2007. So therefore, for my numerator, if I break that down using the power of 2007, that's 10 to the power of 2007 times 10 to the power of, to make 2009, I have 2 more, over root of 10 2007 to make 2011, that's 10 to the power of 4, minus, I'm going to leave this as it is, that's 10 to the power of 2007. So factorizing root of 10 to the power of 2007, I'm left with, that's root of 10 squared, all over, I take out root of, let me put this in a bracket so it's easy to cancel out, 10 to the power of 2007, at the bottom I'm left with root of 10, 4, minus 1. This cancels, that's root of 10 to the power of 2007, therefore I have square root of 10 squared, that's 10, over square root of 10 to the power of 4, that's 10 squared, minus 1, that's 10 over 100 minus 1, and that 10 over 99. Thanks for watching. Bye.